Dear students, this is Basavaraj Mali, Associate Professor, Sheikh Engineering College, Belgavi. So today in solid waste management for 6th semester, I am going to cover the part leachate movement in module 3. Leachate movement is very important in sanitary landfilling. It is a part of sanitary landfilling. So what is leachate? We will see, and how we have to design the solid waste filling in landfill site to avoid the leachate. So leachate is a liquid produced inside that solid waste, either the moisture by rain or the moisture produced by decomposition of that organic matter. So these are dissolved or suspended particles from the solid waste. So that liquid, it is a black in color and it is very harmful. It may affect the groundwater. So composition of leachate is, let's say, the biological and chemical constituents of leachate, that solution. So here constituents like BOD, biological oxygen demand or biochemical oxygen demand, total organic carbon, then chemical oxygen demand, total suspended solids and pH. So these, usually this is a new landfill. These are the ranges, typical range we have given. So 2000 to 30,000 is BOD at 5. So this should be very less. It is too high. So this we have to reduce it as much as possible. So these are ranges. So we have to collect this black liquid and treat it. So after 10 years, say matured landfill, that is about 10 years, the liquid will be having properties. So it is almost reduced, but when it is fresh, it is too much. BOD, CODs will be there. We have to treat it. So how the movement of leachate is there in the landfills? So usually it is downwards, and many chemical and biological constituents are removed by, we have to remove by filtering. When the movement is downwards, so we have to remove it by filtering, by adsorption in the soil strata. Then some other methods are there, like we have to line in the bottom of that solid waste with geomembrane or clay liners. What are the geomembrane or clay liners? That may be, example, synthetic flexible membrane liners. Those are called as FMLS. Bottom seals, artificial earthen liners, then subsurface barriers. So these should be lined below. Example, so here might be a solid fill here above. The bottom, that is the ground surface, should be provided with slopes. See the slopes. Here there will be pipes. These pipes will be having drain. These are called as drainage channel. Will be having 0.5 to 1% slope. That is 0.5 to 1 feet per 100 feet length. That much. And these will be having micro holes. We will see the liquid coming from the solid waste enters these pipes and it will be taken out. So above this there will be a sand fill around 1 to 2 feet, that we'll see. Design of leachate collection facilities. Say this is called as a sloped terrace. This is slopes. So it is sloping is done. Even might be, this may be solid fill. So this is slope terrace, we'll see. So bottom seals, then the geomembrane clay liners, these are used for taking out the. So piped bottom, say this is a sloped terrace, this is called as sloped terrace. Then next is piped bottom. Here 4-inch PVC pipes, 4-inch PVC pipes are laid on the ground On that 2 feet sand layer is put. Here above this 2 feet there will be solid fill cell above this. So whatever liquid coming, it is filtered in the sand, it goes to the pipe, and from pipe it is taken out. So every 20 feet you have to put one pipes, 4-inch pipe. Each pipe will be having a 0.001 inch hole, a very micro hole, so that other solids should not enter, sand particles, etc. So 0.0001 inch hole at every 0.25 inch apart. So at every 0.25 inch apart, small 0.001 inch hole, a laser hole. It is a laser cut hole, and there the pipe should have a bottom slope of 1.2 to 1.8%. What is this 1.2 to 1.8%? So 1.2 feet slope per 100 feet. Percentage means for every 100 feet 1.2 to 1.8 feet slope. So all the liquid, whatever comes down, leachate, it is collected through all these pipes, and it is taken for a next stage. That is, so it is one tank is made which can store 1 to 3 days of leachate produced. So from that it is pumped out for treatment. Either the treatment might be many, like recycling of leachate. This is recycled in STP, sewage treatment plant, or it is left for evaporation. If you have enough space, it is laid to the sunlight for evaporation. Whatever solid remains, it is taken out. So it might be again treated, neutralized in STP, discharged to regular municipal STP. So this how we have to collect and we have to send for. So typical, I am going to show you typical landfill site and how the layout is done. Here see this solid fill. This is a solid fill. Here bottom slopes are made so that whatever liquid goes through this sand liners, it enters the pipes here, which are run like this. So through this micro pipe system it will go, it will be removed. Okay, and here at the bottom there will be a clay liners or liner. It is written here. Here liners will be there, and these pipes. So liners will not allow the leachate to percolate to the ground. Okay, so this leachate movement will be towards the pipe. So little higher it is made, and here you will be having all soil filling, that is solid waste. So leachate collection pipes. This I will give these notes. So here a particular small section here will expand this liner area. Here sand fill is made, solid waste is there. This is solid waste all above. So sand layer is there, then small pipes will be there. Below that pipe clay liner. Okay, so this is also, see here, double line layers. What is this? One is geomembrane liner, another, this is extra geomember. This is optional, it might be used or might not be. So like this liner should be done. After that, this thick one, it is compacted clay layer. So this is how we have to prevent entry of leachate to the ground. Okay, so washed gravel and pipes and all this leachate is collected in this small section here. So this, like that, all it is collected and it is sent for treatment. So this is how we have to avoid the leachate into the ground. Thank you.